AOPS Volume 1, The Basics, number 50. Jack and Jill went up a hill at a rate of 8 units per minute. They came tumbling down at a rate of 8 units per second. What was their average rate for the round trip in units per minute? So before we start with anything, we must first understand the definition for the average velocity of some object. Well, the average velocity is defined to be the total distance traveled, represented by dt, divided by the time which took you to travel that certain distance. And to do so, if we're going to apply it in contextually to this question, we must first find the total distance that Jack and Jill went. So let's assume and let's construct a rough model of what this question is representing. So from the base of the hill to the top of the hill, let's call that x. And likewise, from the tip to the bottom, let's also call that x. And this hill is symmetrical. You'll see why in a second. And so we just assumed the distance of hill to be x units. So that is what I've done. And what I can now do is I can use the time formula, which t is equal to, by definition, the distance divided by the velocity, to find the total time it took them to travel 2x units, because they went up and down the hill, so they traveled 2 times x units. So the time is equal to the distance divided by the velocity. So the first time, let's call the time up. So when they were traveling up the hill, how much time did they take? Well, the distance, we assumed it to be x. And what was their velocity? Well, their velocity was 8 units per minute. But for simplification, I'm going to transfer it to seconds. So 1 minute is equal to 60 seconds. Therefore, when they were going up the hill, they were going up at a rate of 8 units per 60 seconds, which is also equal to, if we divide both sides by 4, 2u over 15s. So their time was x divided by 2 over 15, and which can be simplified to be 15 over 2 seconds. And what was, or 15 over 2x seconds. And what was their time when they were coming down? So td. Well, when they're coming down, they were still traveling the same distance of x, but at a different velocity. They were traveling at 8 units per second. So for consistency, the time they took was x over 8 seconds. And now we can add the 2 times up for the total time that they took to travel the 2x distance, which is x over 8 plus 8 in the denominator, and in the numerator we will have 60x. And I did this for a common denominator of 8, which can then be summed up to be 61 over 8x. So this average velocity is equal to the total distance, 2x divided by the total time which they took to travel 2x, 61 over 8x. X and x cancel, and we're only left with units per minute. Or sorry, in terms of units per second. So this becomes 2 times 8 over 61, which is equal to 16 over 61 units per second. And we need to transfer this to units per minute. And we know that a second is equal to 1/60th of a minute. So I'll write it down here. 1 second is worth 1/60th of a minute. Therefore, therefore 16 over 61 units divided by 1 second, which is worth 1 over 60 minutes. And we can simplify this to be 16 times 60 over 61 units per minute. And we can further simplify this, which is then equal to 960 over 61 units per minute, which is our answer for this question and the average velocity that Jack and Jill traveled throughout the trip.